In most factories, air leaks are a major source of wasted energy and unnecessary costs. They have various causes, from damaged seals, poor connections on your pipework, and even corrosion. For an example, a 3mm hole in your pipework could be costing you from £500 to £900 per year in wasted energy. You can stay on top of this with regular leak detection and repairs to your system.
Incorrectly sized equipment can lead to headaches over wasted energy and problems with your production. When specifying compressed air equipment, it can be tempting to look at the kilowatt rating and just buy like for like. But more importantly, you should be focusing on what flow and pressure you need. To avoid using more energy than is needed over the lifetime of your compressor, it's important to specify the equipment correctly. A compressed air energy audit is an easy and non-intrusive way to assess the flow and demand that's needed on your site. They're a free service and consist of data logging your current compressor and equipment. This will give an accurate feedback on your compressed air demand, pressure and cycle to help identify energy costs and where savings can be made. Data like this is crucial to help answer the question of what size compressor you need.
Understanding your system pressure is critical to your site. A 1 bar reduction in system pressure can result to up to 7% in energy savings. This can save you money, it can reduce your carbon footprint and reduce wear and tear on your production and pneumatic equipment. The best way to manage your system pressure is through the use of a controller or the SmartLink technology on your compressor. So data log your system now and get to know your system pressure.
So why use VSD technology? In many industries, the air demand is fluctuating from peaks and troughs. So what we need is a compressor that contours that demand, and this is where fixed speed compressors are not ideal. When the machine offloads on a fixed speed, this is where it's costing you energy, usually 25% of your full load energy, where the VSD contours the demand. And it does this by speeding up and down the motor of the VSD whilst keeping a perfect pressure band and giving you massive savings up to 60% against the fixed speed compressor.
Up to 80% of a compressed air system total life cycle cost is the energy that it uses, not the initial purchase price or the ongoing maintenance. Typically, compressed air systems last between 7 and 10 years, and during that period, technology advances, meaning that there may be new motors or new controllers available on the market, which can give you a shorter payback period on your equipment.
If a factory has multiple machines without a central controller, you have to cascade the pressures at which they will start. This means that you must keep the overall system pressure artificially higher, as the last machine in the system has to have pressure at a usable level for the process. With a central controller, there is no need to cascade. It will run the system on the smallest pressure required. This will maintain a narrow pressure band, which will increase the stability of your process and also reduce your energy costs. There are different versions of controllers. With the simpler ones, you set the order of the compressors to start, and the system rotates them in sequence regardless of their size. The more advanced controllers continually monitor air demand and choose the most economical combination of compressors to run. For larger customers, it is getting more cost effective for them to install these more intelligent controllers.
As stated by BCAS, compressor performance will deteriorate by more than 10% without proper maintenance. This takes into account things like changing inlet filters when necessary, as blocked filters will restrict airflow into a compressor. Keeping coolers, radiators and ventilation grills clean and clear, as a dusty site will require more frequent maintenance. Using OEM recommended lubricants and genuine spare parts to ensure energy efficiency and reliability. The PPS service team is able to advise and guide you on the correct level of service that is required.
Information from BCAS shows that only 10% of the electrical energy input to an air compressor is converted into compressed air energy. The other 90% is wasted as heat. Approximately 70% of energy is recoverable from oil-injected screw compressors. This comes from research by Atlas Copco. What many of our customers have been doing is simply modifying the outlet ducting. They can discharge hot air externally during summer and then switch this to a warehouse or workshop during winter. A tip from the Carbon Trust is that by placing a compressor in a warehouse, it might provide enough heat to prevent product or packaging from becoming damp. A more intricate system we installed for a customer in the automotive sector involved recovering the heat from the air compressor oil system. This meant they could preheat the water on the return to the boilers and shorten their burn time. It also meant they no longer had to use their immersion heater during summer months.
It's a whole system approach for energy saving and optimum efficiency. From the plant room to the point of use, there are always steps you can take, no matter how small they may seem. Here's a few tips to help you improve. Pressure regulators are often forgotten. Most pneumatic equipment has two ratings, a maximum working pressure and an optimum working pressure. It's important to make sure that your regulator is working at its optimum operating pressure. If only a few pieces of equipment require high quality air, treat at the point of use rather than treating the whole supply. The type of valve you choose can affect your pressure drop and efficiency. The best option is a ball valve, which has almost zero pressure drop when fully open, whereas a diaphragm or a globe valve can cause the highest pressure drop.
When it comes to saving energy, it's more than just fixing leaks in your pipework. So let's have a look at some points to consider when installing your new compressed air pipework system. So firstly, create ring mains. This will ensure that you don't have pressure drop across your system, air is evenly distributed, and you don't have a man at the end of the line losing air to his tooling. Include isolation valves in your system. This will mean that you can modify the system going forward and increase your uptime when you're trying to run. Secondly, use a modern system. Aluminium systems reduce your leakage rates, they're resistant to corrosion and also increase flow rates. Another advantage is they're massively light compared to steel systems. Aluminium systems are also modular, which means that you can make modifications to the system more easily, much more quickly, and reduce downtime to your production.